Mathematics, the blueprint of reality. Mathematics is often seen as a subject of numbers, symbols, and equations. But in truth, it is the invisible framework that supports our entire world. From the way we communicate through smartphones, to the buildings we live in, the medicines we take, the financial systems we depend on, and even the art and music we enjoy, mathematics is quietly at work behind the scenes. In this discussion, we will explore why studying mathematics is essential, not only as an academic discipline, but also as a powerful tool that shapes logic, innovation, and progress. We will examine its profound influence on science, engineering, economics, and society, and then take a closer look at how mathematics forms the backbone of computer science and artificial intelligence, two of the most transformative technologies of our era. Beyond that, we will see how mathematics drives advancements in medicine, finance, climate science, technology, and even the arts, showing that math is not just a subject confined to classroom sit, is the very blueprint of reality. By the end, you will understand that mathematics is not only about solving equations, it is about solving life's greatest challenges. The power and influence of mathematics in our world. 1. Why we need to study mathematics. Mathematics is far more than a collection of formulas or numbers on a page. It is a way of thinking, a lens through which we can understand and shape the world. A foundation of logic and reasoning. Mathematics trains the human mind to think critically and logically. It sharpens problem-solving skills, nurtures analytical thought, and teaches us to approach complex issues step by step. These abilities extend far beyond mathematics itself, influencing decision-making in science, law, business, and even everyday life. A universal language. Unlike spoken languages, mathematics is consistent across all cultures and nations. It provides scientists, engineers, and innovators with a precise, unambiguous way to describe and model the universe. Whether we are explaining the orbit of planets, designing a bridge, or developing a new technology, mathematics is the common medium of communication. Practical applications everywhere. Mathematics plays a role in countless daily activities. We rely on it when calculating interest in banking, planning household budgets, or even predicting the weather. Behind the scenes, it powers everything from smartphones and GPS systems to transportation networks and digital communication. A driver of innovation. Every major technological breakthrough is built on a mathematical foundation. Advances like medical imaging, satellite navigation, and wireless communication exist because mathematicians developed new theories and methods that later became tools for engineers and scientists. 2. The influence of mathematics in our world. The reach of mathematics extends into nearly every aspect of modern civilization. In science, mathematics allows us to describe physical laws, biological systems, and chemical reactions with accuracy. Without math, the precision of physics, the predictions of biology, and the modeling of chemistry would be impossible. In engineering, every bridge, airplane, microchip, or electrical circuit is designed using mathematical principles. Calculations ensure safety, efficiency, and durability in the physical structures and technologies we rely on. In economics and business, mathematics supports risk analysis, financial forecasting, optimization of resources, and data-driven decision-making. Economists and business leaders use mathematical models to predict market trends, minimize risks, and maximize growth. In society and daily life, even outside professional fields, mathematics quietly shapes our routines. Algorithms recommend music playlists, organize social media feeds, optimize city traffic flows, and even match people on dating apps, all built on mathematics. 3. Mathematics and computer science. Computer science as we know it would not exist without mathematics. It is the very backbone of computing. Discrete mathematics provides the foundation for algorithms, data structures, logic, automata theory, and cryptography. Without it, software design and secure communication would collapse. Linear algebra makes possible computer graphics, simulations, and computer vision, as well as powering modern machine learning systems. Probability and statistics enable data science, AI, and all forms of predictive analytics. Number theory forms the heart of cybersecurity, protecting sensitive information through encryption. Complexity theory teaches us the limits of computation, helping us understand what can be solved efficiently and what cannot. In short, every line of code, every search engine, and every encryption method rests on a mathematical framework. 4. Mathematics and artificial intelligence. Artificial intelligence, AI, one of the most transformative fields of our time, is built almost entirely upon mathematics. Linear algebra allows machines to represent data in the form of vectors and matrices, making it possible to process images, language, and speech. Neural networks, at their core, are sophisticated sequences of matrix operations. Calculus is central to optimization. When training models, techniques like gradient descent rely on derivatives to adjust millions of parameters and minimize errors. Probability and statistics give AI the ability to handle uncertainty, make predictions, and learn from incomplete or noisy data. Bayesian inference, probabilistic models, and generative AI all stem from these concepts. Graph theory underlies knowledge representation, network analysis, and algorithms that navigate social networks, transportation systems, or the internet. Information theory introduces key concepts like entropy, compression, and information gain, which are vital in decision trees, deep learning, and natural language processing. Optimization theory ties it all together, enabling AI to find the best solutions in vast search spaces. Every recommendation system, chatbot, self-driving car, and intelligent assistant depends on this mathematical backbone. Without math, AI would not exist. 5. Mathematics in physics and engineering. Mathematics is the language of the physical universe. Classical physics uses calculus to describe motion, gravity, and orbits. Electromagnetism is governed by Maxwell's equations, a set of partial differential equations. Quantum mechanics relies heavily on linear algebra, using Hilbert spaces and eigenvalues to describe the behavior of particles at the smallest scales. Engineering applications draw on geometry, algebra, and differential equations to design safe and efficient buildings, machines, and infrastructure. Real-world examples are striking. The Burj Khalifa in Dubai stands tall because engineers applied structural mathematics. NASA's space missions rely on calculus and numerical methods to plot rocket trajectories. 6. Mathematics in medicine and biology. Modern healthcare is unimaginable without mathematics. Medical imaging techniques like CT scans and MRIs reconstruct images using Fourier transforms and linear algebra. Ultrasound relies on mathematical wave equations. Epidemiology employs probability and statistics to model disease outbreaks, such as the COVID-19 pandemic, and to guide public health decisions. Genetics and genomics depend on combinatorics and statistics to analyze DNA sequences and uncover genetic patterns. Machine learning models founded in math accelerate the discovery of personalized medicine. Pharmacology uses differential equations to model how drugs are absorbed, distributed, and metabolized in the body. Simply put, math saves lives. 7. Mathematics in economics and finance. Global economies run on mathematics. Banking and investment rely on exponential functions for compound interest and sophisticated models for financial products. The Black-Scholes model, based on differential equations, revolutionized options trading. Risk analysis and insurance are based on probability, helping businesses and individuals manage uncertainty. Macroeconomics uses econometric models combining statistics and algebra to forecast trends like inflation, GDP, and unemployment. Cryptocurrency and blockchain depend on number theory and modular arithmetic to secure transactions and ensure decentralization. Every time you make an online purchase, RSA encryption rooted in prime number theory protects your data. 8. Mathematics in environmental science and climate. Mathematics plays a critical role in protecting our planet. Weather forecasting uses fluid dynamics and numerical simulations to predict storms and rainfall. Climate models employ differential equations and chaos theory to understand long-term changes in Earth systems. Ecology uses equations like Lotka-Volterra to describe predator-prey dynamics and ecosystem balance. Renewable energy systems rely on optimization to maximize efficiency in solar panels, wind farms, and power grids. For example, hurricane prediction models save lives by forecasting landfall zones and impact severity. 9. Mathematics in technology and everyday life. Even the devices and tools we use daily are powered by mathematics. Telecommunications depend on information theory for error correction, compression, and efficient data transfer across the internet. GPS and navigation combine geometry with Einstein's relativity to give us precise location data. Computer graphics rely on linear algebra and geometry to create 3D animations and simulations. Companies like Pixar use applied math at every step of production. Social media and e-commerce employ graph theory and probability to recommend videos, friends, and products. Each time you stream a movie, mathematics works behind the scenes through compression algorithms and transforms. 10. Mathematics in arts and architecture. Mathematics also inspires beauty and creativity. Music is deeply mathematical, with harmony, rhythm, and sound waves analyzable through Fourier mathematics. Architecture has long relied on geometry, symmetry, and proportions such as the golden ratio, visible in structures from the Parthenon to modern skyscrapers. Visual arts use fractals, tessellations, and perspective mathematical concepts explored famously in the works of N.C. Escher. Digital art and computer graphics rely on calculus and linear algebra to render lifelike images and animations. Da Vinci's Vitruvian Man remains a striking example of art shaped by mathematical proportions. Summary: mathematics as the blueprint of reality. Mathematics is not just an academic subject, it is the hidden architecture of our universe. In science and engineering, it reveals natural laws and makes innovation possible. In medicine and biology, it protects health and drives discovery. In economics and finance, it safeguards wealth and manages risk. In environmental science, it helps us model and protect our planet. In technology and the arts, it fuels creativity and enhances communication. Mathematics is both a tool and a language, the thread that weaves together every field of human knowledge. It explains the past, drives the present, and prepares us for the future. Conclusion: mathematics is far more than an academic pursuit. It is the foundation upon which our world is built. It sharpens the way we think, provides us with a universal language for understanding the universe, and drives the innovations that shape modern life. From physics and engineering to medicine, finance, climate science, technology, and the arts, mathematics is the invisible thread that connects every discipline. In computer science and artificial intelligence, mathematics is not just useful, it is indispensable. Every algorithm, every neural network, every intelligent system depends on mathematical principles to function. Likewise, in fields as diverse as medicine, economics, and architecture, math transforms ideas into practical solutions that improve lives and push humanity forward. Ultimately, mathematics is more than numbers. It is the blueprint of reality and the engine of progress. To study mathematics is to gain insight not only into the workings of technology and science, but also into the very structure of the world we live in. It is the key that unlocks discovery, innovation, and a deeper understanding of life itself.